Another question I'm sure you would like to see done is 2.1. So we're going to draw a line in between our previous question, and don't forget to answer those conceptual questions as well. But 2.1, let's take a look at 2.1 from your packet. What is the wavelength of light with a frequency of 5.25 times 10 to the 14th hertz? There's going to be a lot of scientific notation in this packet, so get comfortable with using that times 10 button on your calculator. Now we do have an answer, and I want to point out that it's written in nanometers. So we're going to have to convert our answer to nanometers just to make sure we have it right. So first off, we start off with our given and find T-chart. Given and find. It's asking the question straight off the bat. What is the wavelength? So we're trying to find our wavelength, which is lambda. Remember, that Greek letter lambda stands for wavelength. It tells us that it's a light wave. And remember, we always assume the speed of light unless they give it to us separately. So the speed of light, c, is 3 times 10 to the 8th meters per second. Our speed of light is a constant. All right, and then they give us the frequency of the light wave, and they tell us it is 5.25 times 10 to the 14 hertz. So we have the speed of light, we have the frequency of light, and we're solving for the wavelength. It's pretty obvious to me, but I want you to take a look at your packet. In the very front, we have all these equations that we've been looking at. Which one of these 5 equations do you think we're going to use to solve for lambda, the wavelength? Well, if you look at the packet, there's only one equation with that variable in it, and it is the speed of light equation. C equals lambda times F. There's no way we can use any of these equations up above. Even though we are given frequency, it has nothing to do with frequency and period, okay? It's frequency with lambda and the speed of light. We can't use the general speed equation because we don't know distance and we don't know time. So we're going to be using the speed of light equation. C equals lambda times frequency, okay? Now, I have everything I need. I don't actually need to convert anything. These are all the units that I need. So C, I'm going to plug in 3 times 10 to the 8th. That's what's going to go on the left-hand side of my equation. What am I going to plug in for lambda? Lambda, right? That's my unknown. I'm going to leave it there. Lambda is my unknown. That's what I'm trying to find. What do I plug in for F, frequency? 5.25 times 10 to the 14th hertz, right? That's my frequency. We've done so many equations like this before. If I'm trying to get lambda all by itself, algebraically, what do I need to do with this number over here to move it to the other side? Lambda is multiplying on this example. So if it's multiplying by 5.25 times 10 to the 14th, to move this number, we have to do the opposite, which is divide. So we're going to divide by 5.25 times 10 to the 14th. And what we do to one side, we must do to the other side, right? 5.25 times 10 to the 14th. Be careful with this on your calculator because lambda is equal to this scientific notation number divided by this scientific notation number. If you're using your buttons correctly, you shouldn't have to use any parentheses, but you are more than welcome to use parentheses if you like, okay? I'm going to put this over here so you can see me typing it in. 3 shift log, and remember, these are my calculators. You may have your own calculator that is a little bit different, okay? Times 10 to the 8th, right? Divide 5.25 shift log 14. This should give us the answer. Boom. 5.71425, blah, 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 blah. And then don't forget the times 10 to the negative 7th. Okay? I told you nanometers is what we're looking for. And this is perfect because nanometers is actually times 10 to the negative 9th usually. And we're going to talk about that in just a second. But 5.714 blah, blah, blah. So let's go ahead and write that. Lambda is equal to 5.71. Okay, I'm just going to round it to those two numbers. Times 10 to the negative 7th. Now, could you just leave this here and write it in meters? Absolutely. It's the same thing. But I know that the answer was given to you on your packet in nanometers. Okay, nanometers. The problem with nanometers is that's times 10 to the negative 9th. So this number is actually the exact same as 571 nanometers. They are the same number written in a different format. That's all. Okay, so we checked our answer. That's exactly what we needed. And that is how you do 2.1. There are other questions in this packet very similar to 2.1 that you're still going to be using the speed of a wave equation. And you're still going to need to plug in 3 times 10 to the 8th meters per second for the speed of light.